moving or not. So how do we calculate or how do we implement the knowledge into the question? Unless we don't have the basically idea about it, right? For that, we have to understand and analyze that how do we determine whether the object is moving or not. Okay, so for such thing, I have basically taken an activity over here so that you can understand it properly. With okay, so how to basically you can say identify it. Okay, so first of all, let's I'll just mark it when the object is in rest, and I'll mark it right when the object is in motion. Okay, and Chakrika.
Yes, sir.
Sure, that's great. So now please tell me. So let me know the whether this is in motion or in rest.
Rest.
Rest. That means it's cross. Okay. Next one.
Rest.
Rest. This one.
Rest.
Rest. This one.
Motion.
Okay. The student has joined. Just give me a second. The student has joined. Javeriya. Hello, Javeriya. How are you? Assalamu alaikum.
Hello, sir. Good evening. Alhamdulillah, I'm
Good
fine.
evening. I'm good. I'm good. Thanks so much for asking, Javeriya. How are you? Please turn on the video, Javeriya. Okay, that's great. Okay, so you're a little bit late, Javeriya. It's been 15 minutes late.
Yes, sir. I didn't know like today was the class. That's what.
Chalo, no worries. Go back. So no worries. I've just started the class. Okay. So so we are going to start the new topic. As I've told you that in the next class itself, we'll be starting a new topic, Chakrika and Javeriya. So in this class, we are going to study about the rest in motion, right? How do we analyze whether the object is in rest in motion? This is the most fundamental thing that you will be studying in the motion chapter, right? Because if you have the idea that which body is moving, which body is not moving, then you will be able to implement it properly into the real life examples. Clear? So
Yes, sir.
that's great. Okay, so let's start it again once again. Okay. So Javeriya and Chakrika, I'm gonna basically mark these things, these examples as cross and right. If it's moving, so it would be right. If it's not moving, it would be a cross. So I'll be asking one by one. So you have to answer to me. Okay. Is that clear to both of you?
Yes, sir.
Chalo, that's
Yes.
great. Okay, that's great. So now let me know. So is this tree moving or in rest? Fast. Is this tree moving or in rest?
Rest.
Javeriya? Rest. Okay, Chakrika has already given me the answer. No worries, Chakrika. We'll just okay. Still this. Let me know the answer for the this one, Javeriya.
Rest.
Rest. Next one.
Rest.
Rest. This one.
Moving.
Moving. Now both of you, please let me know the answer for this case. Is it moving or in rest?
Moving.
Moving. By the Chakrika.
Moving.
Moving. Okay. That's good. Okay. Next one. Moving or rest?
Moving.
Moving. Next one.
Moving.
Okay. It's good. Chorus. Moving or rest?
Rest.
Rest. Yeah, that's great. And this one?
Rest.
Rest. That's great. So now everyone, we have to understand one thing. Like if we have easily identified that whether the object is moving or not. The thing is that we don't have the idea about it. So we should have any reference to which we can easily identify it. Yes or no? You can see from the figure itself, yeah, they are moving because they are walking. So could you please tell me one thing that is very common in the moving objects? What are they doing over the time? In simple words.
Moving from one place to another.
Okay, Javeri, that's one. Chakrika?
The time goes on.
Like basically
When
time is
move.
passing. So what are they doing if the time is being passed? What are they doing actually if they are moving? They are changing the position, going from one place to another place. Yes or no, Chakrika?
Yes, sir.
Right? Okay, that's great. Javeri, you get a right answer. That's great. Okay, no worries, Chakrika. Yeah. So that means when the body is moving, that means the body is changing the position over the time. So we have, you know that time is a quantity that is not stoppable. You can say you cannot stop the time. It's completely unstoppable, right? It will pass away. Okay. But so basically that's why we have taken the time quantity as a reference so that we can understand whether the body is moving or not. Okay. So with respect to time, if the body is changing the position, that means the body is moving. And with respect to time, if the body if the body is not changing the position, that means it is in rest. Clear?
Yes, sir.
That's great. Okay. So that's how we can identify in terms of the time, because okay, that's all, like all that is enough itself to understand whether the body is moving with respect to time or not. Okay. So the first thing is would be the object. Respect to time, you can say. That means if the object is changing, that means the body is moving. Next is the body is not changing the position with respect to time. It's considered to be. Please do let me know, everyone. Is that clear to you or no? That's
Yes,
the
sir.
Yes.
basic thing. So that's the thing, that how you can differentiate between the rest and motion if a body is moving or not. Okay. So this was the basic thing. Okay. Now let's come to the distance and displacement, right? So I have already had the notes, but the thing is that, so if I write it again, so that will be a lot of time taken. So what I will do that, I will explain you the concept thoroughly on the different page. And after that, once we've done the complete explanation, so we'll just get back to it, and basically you will just write it down. Okay. That will help you to understand it quickly. Okay, everyone?
Yes, sir.
Okay.
Yes.
Yeah, that's great. So now let's understand the next topic, that is your distance and displacement. I'll just explain it right away. Wait, just give me a second. Let me take a new page. Because I've just like this is the batch note that I've just recently started. So that's why I thought that we should just complete it by this class itself, and you will get merged with the batch itself. Okay. That's great. So
Yes.
everyone, let's understand what do you mean by distance and displacement. This is one of the most important topic that you will be studying first to understand the other topics. Okay? Because distance is the fundamental thing that you will be studying in the motion chapter, and the displacement as well. Okay? So all the complete chapter, the whole chapter of the motion is based on distance, displacement, speed and velocity. These four terms will be continuously there in your questions. What is this? What is displacement? What is distance? And you'll be just completely saying that, sir, we are getting bored by this. But actually, this chapter is based on these four terms only: distance, displacement, speed, and velocity. Okay. Now let's understand what is basically distance. Okay, let me give you the image. Just give me a second. So distance. displacement image. Okay, I've got one image. Just give me a second to paste it. Is it visible to both of you?
Yes, sir.
Good. So now let's explain this thing. Let me explain this thing. Okay, everyone. So this is an image in front of you in which you have basically two paths, basically, to go from initial to final position, right? So in the real world as well, we have multiple ways to start from one point to another points, right? We can go to any point with the multiple paths, yes or no? Suppose that you are living in Delhi, so you can go to Mumbai by the road as well, by the train as well, and by the air as well, and all the three parts would be different, yes or no?
Yes, sir.
Okay, that's great. So now Chakrika and Javeriya, you can see that I'm starting with this path first. I'm going like this. So this is a curved path. Yes or no? Suppose that this is a route that you have taken to go to your friend's home. So this is basically your home. And suppose that this is your market. Instead of friend's home, let's take it market. Okay. So you're going from your home to your market. So you have taken a curved road, or basically the actual path that is present outside. Yes or no, everyone?
Yes.
Yes.
Okay. Now, what is distance basically? Distance is the actual path taken by the body. So when you go to any place, whatever the path that you have taken will be called as distance. Clear? That's what distance is. So in terms of distance, you can say that if you're going like this and if you're coming like this. So could you please tell me that will the distance increase or decrease, or will it remain same if you're going and making a U-turn after this?
It will
It will
increase.
increase.
Increase. That's the thing. Distance is a scalar quantity. That's why it will only depend on the magnitude. Okay. So do you know what is scalar and vector quantities?
Yes, sir.
Okay. Scalar quantities, you just have to understand scalar quantities are those quantities which depend on magnitude. Vector quantities which depend on magnitude plus direction. So we are talking about distance. So distance is a scalar quantity. That means if you are going in this manner, it doesn't matter in which direction you are going. So it will always get add up, whether you have taken a single step itself. Is that clear to both of you?
Yes.
Yes, sir.
That's great. Next thing about distance is, so distance of a moving body will always be greater than zero. If a body is moving, if you've started from this point to this point, if you're going like this, so distance of a moving body will always be greater than zero. It cannot be less than zero if a body is moving. And even though it cannot be zero as well if the body is moving, it will always be greater than zero. Okay. So like this, if you're going in this and you have taken a turn to this, so this is 10 meter, this is 20 meter. So in terms of distance, you have covered 30 meter, the actual path you have taken. Clear, Javeriya and Chakrika?
Yes.
Yes.
That's great. That's great. Okay. So just give me a second over here. So let me do. So now that's what distance is. And could you please tell me the unit of the distance in which we measure the path? Do you know any? Do you have any idea?
Meter, kilometer.
Kilometer per
Let me kilometer and meter by Javeri and kilometer by Chakrika. So kilometer. Okay. So kilometer is the unit, but the SI unit that we use or internationally used is meter. Okay. So always remember that distance is measured in meter. Okay. Clear?
Yes, sir.
Yes, sir.
Good. No need to write down anything. I'm just explaining all the terms, and after that, once I have the note, which I'll basically share with this on a screen, you can just write down the definitions from there. Okay. Now let's come to the displacement part, everyone. So displacement part, let's take an example, everyone. This is point A. This is point B. This is like the path. Okay. And one path is there which is directly connecting. It's a straight line. Sorry for my bad drawing. Okay. So it's connecting directly. So displacement in simple words is the shortcut distance. So if you are there at BA and you wanted to go to B with the shortest amount of distance, that would be a straight line connecting these points. Okay. Distance is the shortest path between the initial and final path. Clear, Javeriya and Chakrika?
Yes, sir.
Okay, that's
Yes.
good. Okay. So next thing about displacement is, I'm just writing in short, displacement is a vector quantity. Okay. So it can be 0, positive, or negative. So all the things could be happen to the displacement because it's a vector quantities. So direction will matter. DIR and short form of direction that I'll be using, direction matters over here. Clear, both of you?
Yes.
Yes.
That's great. Okay, next thing would be, as you can see, displacement is nothing but a part of distance because it's the shortest path. So it is also measured in meter. Is meter. Clear, all of you?
Yes, sir.
So next thing would be, so in this case, you can say there was a curved path over there, but right now the one more path is available that is between initial and final point. That is a straight line path. So straight line path connecting the 2 points is called basically displacement of the body. Okay. Just give me a second. Let me raise it. So can anybody tell me, suppose that everyone, in which case the distance and displacement will be equal? Any idea? Javeriya and Chakrika?
If they both are straight,
Okay, Javeriya said when they are both are moving in a straight line. What about you, Chakrika?
The
What do you
circular
think?
path.
Huh?
Circular path.
The circular path. Okay. Okay. So chicken, no worries. So Javeriya has given the right answer. Chakrika, circular path, distance and displacement would be different. Okay, no worries. I'll explain it. Okay, no worries. Okay, good, Chakrika. No, sorry, Javeriya as well, and as well as you, Chakrika. So when the body is moving, suppose that everyone, let's take an example. A part, B part. Only single path is there, and the body is started from, this is I and this is final part, and started from A and gone to B in the straight line. So this is the initial position and this is the final position, everyone. And that's the actual path that you have taken from A to B, yes or no? And that is the only straight line path available that is connecting between A and B. So in that case, distance will be equals to displacement in terms of magnitude. Okay, in terms of magnitude only. What is magnitude? Basically the number. Suppose that it's 10 meters, so 10 meters, so distance will be 10 meter as well as your distance displacement as well. Is that clear to both of you?
yes, sir.
Okay, Javeri and Chakrika, clear?
Yes, sir.
Chalo, that's good. Okay. So let's see. So just let me raise it. Okay. So let's get back to the original question. So over here, these are the, you can say the definitions given in front of you. So first thing is basically distance is basically the actual path taken by a body irrespective of the direction. As I've told you, distance does not depend on direction because it's a scalar quantity. Even though if you're changing the direction, distance will get added up. Yes or no, everyone? Clear? That's why it is saying irrespective of the direction in which the body travels. So please note this down, the first 4 points of the distance. And after that, I'll explain the displacement part.
Excuse me, sir.
Yes, Chakrika, Javeriya.
What is scalar quantity?
It's scalar.
What does it mean?
Scala. Scalar means it depends only on magnitude. That means, just give me a second. Suppose that only the quantity depends on magnitude. That means if suppose a 2 kg mass is there and 3 kg mass is there. So is there any other way to compare these quantities except from the magnitude? Just the number. Which one is bigger?
3 kg.
3 kg. That means the quantities which is measured in terms of magnitude. Okay. That is called scalar quantity. It depends only the number. Mass, does mass depend on anything apart from number or the quantity? The quantities which are basically measured in quantifiable manner. Like it could be 2 kg. Distance is like suppose 10 kilometer. Have you ever heard minus 10 kilometer distance covered by the body?
No.
No, you always measure in terms of a number, the magnitude. So only it depends on the magnitude of the quantity. Clear, Javeriya and Chakrika?
Yes, sir.
That's great. Check. Oh, yeah, Chakrika is saying something?
No, sir.
Okay. So after this class, everyone, you'll be having the assessment of the distance and displacement. Please go and check out the assessment as well, okay?
Okay,
The
sir.
5 MCQ questions will be there, and whatever we have done will be, those questions will be based on your like CBSE patterns, conceptual, assertion, reasoning, like that. Okay?
Yes.
That's good. Okay. So done with the writing part, Javeri and Chakrika?
Yes, sir.
Check it. Now let's talk about the displacement. Okay. So as I've told you that displacement is the shortest path between the initial point and the final position of the body, along with the direction. In the displacement, everyone, direction will matter. If you are going in this direction or in this direction, this will matter a lot. Okay. So we usually do one thing. We usually consider right side as positive. It's up to us. But in terms of general manner, I'm saying, usually we say that right side is positive and the opposite would of it would become automatically negative. Yes or no? Okay, clear
Yes.
everyone? Okay, so that's why the displacement could be you can say could be zero, can be negative as well as positive depending on the situation. So displacement is a vector quantity. That means it will depend on magnitude as well as direction. As I've told you, it is depending on the direction. It is positive or negative. It will depend on direction. That's why direction also matters in the displacement. Clear, both of you?
Yes, sir.
Yes.
Good. Now, please note it down. And as I've told you, the distance and displacement of a moving body are equal in magnitude only when the body is traveling in a straight line. When the body is traveling in a straight line, in that case, the distance and displacement would be equal in magnitude. And over here, displacement of a moving body can be positive, negative, or zero. Please note it down and let me know. After that, we'll study about the positive displacement, negative displacement.
Excuse me, sir. Done.
Okay, just give me a second. Here, just a second. So now let's talk about the positive and the negative displacement, right? So what is basically positive and negative displacement one by one? So first of all, everyone, suppose that you have started from point A and you have gone to point B, right? So I have taken this side as positive, so it would be positive 20, right? And you have gone to B point. After that, you have basically come back to B point. So this would be C. Okay. So now could you please tell me, everyone, so what is the total distance that you have covered in this case, A to B, then B to C in the total journey?
10
meter.
or 30.
30 by Javeriya and 30 by Chakrika as well then? What did you say, Chakrika? 30 or 20?
So 30.
30. Okay. Yeah, 30. Because I've told you that distance does not depend on the direction. It will get add up. Okay. So wherever you go, it will add up. So the total would be 20 plus 10 would be 30 meter. Clear? Now your final position is C. Suppose that basically I've drawn these two lines as different, but actually they are same line. Suppose that you have gone to market from this path and you are get back to home on this same path. But right now, instead of going back to home, you have basically stopped at C. So could you please tell me the displacement? What is the displacement in this case?
So can you repeat the question?
I'm saying that what is the displacement if you have stopped at point C?
10 meter.
Okay, 10 meter by Chakrika. What about you, Javeriya?
Sorry, I don't know.
Okay. So it would be 10 because Javeriya and Chakrika, see this thing, you are going in this direction. So you pause would be the distance covered by you would be 20 meter positive. But right now we are talking about displacement. So you are going in the opposite direction of motion that I've considered would be negative 10, yes or no? So ultimately, this is your final position, that is C point. This is the initial point. This is the final point. The shortest distance between these 2 points is 10 meter. So that is 20 plus minus 10 equals to 10 meter. Is that clear?
Yes, sir.
Okay. So that's how we basically you can say understand the positive displacement part. Now let's talk about the negative displacement. Please let me know the total distance covered in this case.
30.
30. And what is the displacement?
10.
Minus 10.
Minus 10 by Chakrika. Javeriya said 10. So it would be negative 10. Why negative 10? Everyone see this thing. The 30 was right, but right now I have taken this side as positive and this side is negative. So the negative sign does not mean it is less than 0. Negative 10 obviously will say that, sir, it should be less than 0, but it's not actually depicting negative 10 as a number. It's saying that 10 is the magnitude of the body displaced from its original position, but in the opposite manner. Negative means opposite manner, because actually you have considered this is the direction of motion, but you are going in the opposite of it. Is that clear? Why the negative number is associated with this 10? Negative sign? Because the actual position is A and the final position would be C. So you have considered this as positive, but you are going in this direction. So this would be negative 10, because it's 10 minus 20 now. Did you get my words, Javeriya and Chakrika?
Yes.
Done? Sure? Clear to both of you?
Yes, sir.
Sure. That's good. Check it. Now it's time for the zero displacement. Now let me know the answer of the total distance covered.
40.
40.
40. What is the displacement?
0.
0. Chakrika, what about you, Javeriya?
0.
0. So that's great. That's correct. Because, see this thing, everyone, you have gone back to the same point from where you have started. That means you have covered basically the actual position, the change in position actually 0. Distance will always be positive, that will be greater than 0, that is 40. But in actual, you have basically gone back to the same point from where you have started. So that's why 20 minus 20 would be 0. So in circular case, if we talk about Javeriya, Chakrika, you have given me the answer when the body will be, and the body's distance and displacement would be equal. In that case, you were wrong, because if you start point A, you have basically completed a one circle, you are at the same point. So your distance would be 2 pi r, but your displacement would be 0. Did you get my words? Because you are at the same point from where you have started. Clear, Javeriya and Chakrika?
Yes.
Yes, sir.
Sure. Just give me a second. Yes, everyone. Clear, both of you?
Yes.
Yes, sir.
Sure. Please note it down fast. This is important to understand. That's why. Is that clear? Completely clear. Please be honest with me, everyone. Chakrika and Javeriya.
Yes.
Crystal clear?
Yes, sir.
Chalo, theek hai. Please note this down and fast, and let me know once done. After that, we'll do a question based on that.
Excuse me, sir.
Yeah. Okay, Javeriya, just go. Chakrika done?
Yes, sir.
Okay. Okay, so I would like, okay. So before that, okay, this equation is very, very important to understand everyone. Distance is equals greater than or equal to displacement. Okay. So what does it mean basically? So displacement can only be equal to distance. It will not exceed the magnitude of the distance. Clear, all of you? Okay. So that's why distance will be equal to displacement when the body are when the body is traveling in a straight line. Okay. And they will the distance will be greater than the displacement if there is an uncertain path like this. Okay, so you can see this thing. So over here, this is greater than the displacement path, obviously straight line path. So this will be called as distance. So this is greater in magnitude as in terms of displacement. Clear, both of you?
Yes,
Yes,
sir.
sir.
Okay. Please note this down, this displacement part, and after that, please try to solve this question and let me know the answer. Okay, Chakra, don't use question mark. Just let me know the correct answer. Javeriya, let me know the answer.
B.
ठीक है. B. That's the wrong one. C answer is the correct one. Let me tell you why. Everyone, see this thing. Half when you cover through the circumference, this would be pi r. What is the value of pi in terms of decimal?
22/7.
3.14.
3.14 r. I've told you that displacement will always be a straight line. So displacement over here would be a straight line connecting the opposite point, that is 2r. So which one is smaller, 2r or 3.14 r?
2R.
2r. That's what the question is asking after half circle. It would be a 2r. Clear?
So, but it will be 2 times. All right.
2 times r, yeah.
So how?
How? Because there is a straight path connecting after completing half circle, na, A to B. You can easily go, instead of going circumference, you can easily go to the diametrically opposite points. I've told you that displacement is always going to be a straight line. Displacement, shortest path between 2 points, straight path, isn't it? So which one is greater? If you go through the circumference Javeriya, it will go through it. This is pi r. So value of pi is 3.14 and r. That means 3.14 times of r. But if you go through diameter, you are getting 2r. So which one is greater? 3.14 r is greater because that will act as a distance and 2r will act as a displacement. Is that clear though?
Yes.
Okay.
Yes.
Chakrika, for you, is that clear to you or not?
Yes, sir. Yes.
Okay. So after this class, everyone, please go and check out the assessment. Okay. And I'll also give some homework questions to you as well, and you will get it by tonight itself. Okay. So, okay, so let's end this class over here with this. Okay, so we'll meet in the next class and be starting a new topic, that is just speed and velocity. So I hope this is clear to both of you.
Yes, sir.
Yes, sir.
Sure, that's great. So with this, let's end this class and let's meet in the next class. Till then, take care. Bye bye.